Hi, my name is Trine Pedersen, and I'm a visiting scholar in Dr. Stein's Monogastric Nutrition Laboratory. And I will now present the interesting result from my master thesis conducted at the Aarhus University in Denmark in 2014. The presentation will address the topic of feeding lactating sows. In this presentation, I will give a short introduction to the study, followed by the objective and hypothesis of the study. Thereafter, I will describe the materials and methods used in this experiment. Then I will present some of the results from my study and a discussion thereof. And in the end, I will present the conclusion of my results. Today, there is a lot of pressure on sows. They produce more milk and they give birth to more piglets. Despite this, we still feed sows the same way. During the lactation period, it is common for sows to mobilize a lot of nutrients from their reserves, and a typical weight loss for sows throughout lactation can easily reach 20 to 30 kilograms. This weight loss is expensive and can furthermore affect the following reproductive cycle. Commonly, feeding of sows is limited to one feeding curve. This feeding curve has to cover old as well as young sows' requirement for nutrients, which actually is very different and is dependent on the size of the sows and how many piglets there are in the litter. Furthermore, the feeding strategy has to cover the dynamic increase in nutrients throughout the lactation period. For instance, the requirement for lysine increases threefold, while the requirement for energy doubles. In the end, this means that the commonly used feeding strategy for lactating sows is insufficient to meet sows' requirement for nutrients, which cannot be met when fed only one diet throughout lactation. In this figure, I have illustrated the problem in question. We have the energy content on the y-axis, days after farrowing on the x-axis, and on the secondary axis, we have the amount of feed in kilograms. The dark blue curve illustrates the traditional feeding curve applied in Denmark, and the light blue line reflects the actual requirement of a 230 kilo second parity sow with a litter size of 14 piglets. What is characteristic here is that sows are fed less than the requirement in early lactation, corresponding to 2 kilos of feed. This is partly to avoid sows' feeding intake dropping later in lactation. And sows are fed approximately 2 kilograms more than the requirement in late lactation when sows prepare themselves for next reproductive cycle. As you see from the figure here, it is very inefficient to feed both under and over the requirement. So after this introduction, it leads me to the objectives and hypothesis of the study. The study's objective is to investigate whether sows fed a combination of two diets perform better than sows fed a single diet throughout lactation. And the hypothesis of the study was that an uncoupling of the dietary supply of lysine and energy using a two-diet feeding regime will improve milk yield and nutrient balances and reduce sows' weight loss. In this experiment, we used 14 second parity sows, and each litter was standardized to 14 piglets per litter. The experiment started on day 2 after farrowing and continued until weaning at day 28. The sows were allotted to two dietary groups. One group received feed reflecting the traditional feeding standards in Denmark, which will be referred to as the one diet regime throughout this presentation. The other group of sows were fed according to their individual requirement for energy and lysine. The feed consisted of two components, a basal diet to cover the requirement for maintenance, and a lactation supplement to cover the requirement for milk production. This group of sows will be referred to as fed by the two-diet regime. The dietary composition of the diets and supplements appear in the table. To calculate the individual sow's requirement, we weighed the sows to estimate the amount of basal diet needed to cover the requirement for maintenance. To calculate the amount required to cover the milk production, we used the model of Hansen et al. This model only requires two inputs, the litter size and the litter gain to estimate the milk yield on specific days of lactation. The feed requirement was predicted 1 week ahead every week for the 2-diet regime. During the experiment, we collected milk samples on day 3, 10, 17, and 24 to measure the milk composition and the contribution to the nutrient requirement. Sows were weighed on day 2, 7, 14, 21, and 28 for feed calculation and weight loss. Piglets were weighed on day 2, 4, 7, 21, and 28 to estimate milk yield and calculate the piglet gain. Sow's back fat was measured on day 2, 14, and 28 for using calculations of fat and protein mobilization. And sows were enriched with deuterium on day 2 and 28 to calculate the pools of fat and protein and thereby the mobilization throughout the lactation period. Finally, we collected blood samples on day 3 and 17 to get an indication of the sow's nutritional status. Data were analyzed using mixed and gain-mod procedures in SAS, where the experiment was regarded as a complete randomized design in which sows were stratified by body weight. Dietary regime week and the interaction thereof were considered as fixed effects, and the random component was accounted for by the individual sow. Moving on to the results. If we take a look at sow's feed intake, it shows that the total intake throughout the lactation period was the same. The average feed intake was 7 kg for 1-diet sows and 6.9 kg for sows fed the 2-diet strategy. The feed intake is illustrated in the figure, where we have kilograms of feed on the y-axis and days after farrowing on the x-axis. It appears that the progress of the curves are different, and 1-diet sows receive less feed in early lactation and more feed in late lactation compared to 2-diet sows. Moving on to sow and piglet performance. The milk yield for sows is illustrated in the figure, where we have kilograms of milk on the y-axis and the day after farrowing on the x-axis. Milk yield was not different in the first weeks of lactation, but is significantly higher for sows fed the 2-diet feeding strategy in week 4. It is notable that the sows fed the 2-diet regime produced more milk in week 4, even though they were fed less feed than sows fed the 1-diet regime. Weight loss for sows was not different between dietary regimes, but the week in which sows lose weight is different. The 1-diet sow lose weight in early lactation, where it is possible to almost eliminate the weight loss in the first week of lactation for 2-diet sows. There was no difference in the weaning weight, which was 7.3 and 8 kilograms, for piglet fed the 1-diet and 2-diet respectively. Piglet weight gain throughout the lactation period, however, was greater for piglets from sows fed the 2-diet strategy, which also indicates that sows fed the 2-diet strategy had a higher milk yield throughout the lactation period. In this experiment, energy, nitrogen, and lysine balances were calculated. These figures summarize the balances for the nutrients converted into the additional amount of feed which should be supplied to reach a 0 energy, nitrogen, and lysine balance. The left figure shows the additional amount for 1-diet sows, and the right figure illustrates the profile for 2-diet sows. For each dietary regime, we have the additional amount of feed required to reach a 0 nutrient balance on the y-axis and weeks after farrowing on the x-axis. It appears from the figures that both groups of sows were in negative energy balance throughout the lactation period, where 1-diet sows reach 0 in week 4 and 2-diet sows keep a constant negative energy balance. The profile for nitrogen and lysine is relatively more different from each other. 1-diet sows are undersupplied until week 3 and 4 for lysine and nitrogen, respectively, and 2-diet sows are positive throughout the entire lactation period. In relation to feed, this can be converted to how much more the sows required to obtain 0 balance. In regard to energy, it can be seen that 1-diet sows should have been supplied 3 kilograms more, where 2-diet sows should have had 1.5 kilograms more. The shape of the curves for nitrogen and lysine appear to be more different than in the case for energy, and sows fed the 1-diet regime. and it is worth noting that it is possible by the two-diet regime to make the curves more parallel and to reduce the nutrient deficiency. If we take a closer look into the sow, the plasma metabolites can also support the results. First, it was observed that the sows fed the two-diet feeding strategy had a lower plasma concentration of glucose in week 1 compared to the sows fed the one-diet strategy. A lower concentration of triglycerides was also observed for two-diet sows in week 2. These two parameters are both indicators that there is a greater pool of nutrients to the udder throughout lactation for sows fed the two-diet strategy. Sows fed the two-diet strategy also had a higher level of urea in the plasma. This is an indicator that the sows were oversupplied with nitrogen throughout the lactation period, which also could be seen from the previous figure about nutrient deficiency. The higher concentration of lactate for sows fed the two-diet strategy could also indicate that more protein is oxidized and the carbon skeleton is used for lactate formation. In conclusion, feeding of lactating sows with a two-diet feeding regime throughout lactation improves sows' milk yield and thereby increase the mean piglet weight. It is furthermore possible to reduce the feeding cost for sows and piglets. By feeding sows with the two-diet feeding regime, it was also possible to improve the nutrient balances and thereby reduce nutrient deficiency throughout lactation. Feeding sows with the two-diet regime should also make it possible to reduce sows' weight loss during lactation, which can improve reproduction and sow longevity. Thanks for your attention. For further information and questions, you are welcome to write me at the following email address: tfpeters@illinois.edu.